There is more than one way to solve a system of three linear equations, but when we're doing this preparation for systems of three linear equations, we're going to first focus on using the method of elimination by addition that you've seen when dealing with a system of two linear equations. And the way I'm going to show this preparation is to actually do an example. But I'll do that example by again showing how you use the method of elimination by addition. So let's say if you're given the system of equations where the first equation is 5x minus 2y minus 4z equals to 3. Second equation is 3x plus 3y plus 2z is equal to negative 3. And the third equation is negative 2x plus 5y plus 3z is 3. Now, what I'm going to first do is, let's pretend we only have the first two equations. And what we want to do is to eliminate the z variable using the method of elimination by addition. Now remember, the method of elimination by addition is that you take one or maybe both of the equations and multiply them by non-zero constants so that when you add the two equations together, one of the variables is eliminated. So looking at these two equations, equation 1 and 2, and we want to eliminate the variable z, well, looking at it for the first equation, the z term is negative 4z. For the second equation, the z term is 2z. So if I want to eliminate the z when I combine the two equations, what I would do is I would multiply the second equation by 2. So what we'd end up with, so we leave the first equation alone, so we have 5x minus 2y minus 4z equals to 3. And then for the second equation, like I said, I'm going to multiply that entire equation by 2. So we'd have 6x plus 6y plus 4z equals to negative 6. And when I combine those two equations, I combine the x terms, so 5x plus 6x, that would be 11x. Then we have negative 2y plus 6y, so that would be plus 4y. The z terms, like we said, those are eliminated. And then we would have bring down the equal signs, and then the 3 plus negative 6, that would be negative 3. Now what I'm going to do next is take another two of the equations, not the same two. Let's say if I want to take the second equation and third equation, and I want to again eliminate the z's. So looking at that, again for the second equation, the z term is 2z. For the third equation, the z term is 3z. So to eliminate the z's, I got to do more than just multiply one of the equations by a number. I got to multiply each equation, by a number. And so in this case, what I would do is I'd multiply, let's say maybe the second equation by 3 and the third equation by negative 2. So what I would end up with when I do that, when I multiply the second equation by 3, or negative 3, you would have negative 9x minus 9y minus 6z equals to 9. And if I multiply the third equation by 2, I'm going to get negative 4x plus 10y plus 6z equals to 6. And then when I combine these two equations, let's see, so we'd have negative 9x plus negative 4x, so that'll be negative 13x. Negative 9y plus 10y, that'll be plus y. The z terms are eliminated. Bring down the equal signs. 9 plus 6 would be 15. Okay, so what I would now have is, after doing that, I have these two equations. One was the 11x plus 4y equals to negative 3. So let's look at that. 11x plus 4y equals to negative 3. And the other equation of negative 13x plus y equals to 15. And now what I want to do is to solve this system of equations. And now this is just like what you did before when you're solving a system of two equations using the elimination by addition method, because we only have two equations and two unknowns now. So let's solve this system. And let me rewrite it again down here. So we have that 11x plus 4y is negative 3, and negative 13x plus y equals to 15. And then one way you could do this is, if I want to solve this system using the elimination by addition method, let's multiply the second equation by negative 4. So leaving the first equation alone. And then multiply the second equation by negative 4. Let's see, this will now be 52x minus 4y equals to negative 60. And then combining these two equations, let's see, we got 11x plus 52x, so that'll be 63x. The 4y minus 4y, those cancel. Negative 3 minus 60 would be negative 63. So solving for x, we now get x equals to negative 1 by dividing both sides by 63. And now that I know what x is, I can now, like what we did before, we could solve for what y is by plugging in this value for x into either one of these two equations. Let's say, what if I plug it into that first equation? So it'd have 11 times negative 1, so negative 11, plus 4y equals to negative 3. Add 11 to both sides, so I get 4y equals to 8. Divide both sides by 4, you get y is 2. So I now know the x coordinate, I know the y coordinate. But remember, we have originally a system of three equations with three variables. So we need to know what is the z. So what we're going to do, let's see again. So x was negative 1, y was 2. So let's write that up here. We need to know what z is. Well, what do you think you do? Exactly. You plug in the negative 1 in for x, the 2 in for y into either one of these equations. Let's say the second one. So 3 times negative 1, so that would be negative 3, plus 3 times 2, so that would be plus 6, plus 2z equals to negative 3. So let's see, negative 3 plus 6 is 3. Subtract 3 from both sides, you get 2z is equal to negative 6. Divide both sides by 2, you get z is negative 3. So we have the order triple, negative 1, 2, negative 3. So I've really showed you some of what you need to know to solve a system of three equations using the elimination by addition method. And what it is using the elimination by addition method 3 times. Take 2 of the equations, eliminate one of the variables. Take another 2 of the equations, eliminate the same variable. Then you end up with 2 equations with 2 variables. Use the elimination by addition method on that. Then you'll solve for 2 of the variables. And then to solve for the third variable, you just plug in the 2 variables you solved for into any one of the original equations and solve for the third variable. Now there's more to it than that. There's going to be, okay, as we saw before, there's special cases. There'll be no solution, infinite number of solutions. The infinite number of solutions is actually more complex in this case, because when you graph these systems of 3 equations with 3 variables, we're actually talking about a 3-dimensional graph now, because we have an x, y, and z coordinate. So we're now talking about, like I said, 3 dimensions. So, but this gives you a good preparation for what you're going to be in store for when you're dealing with the systems of 3 equations and solving it with the elimination by addition method. There are other methods you'll see later on, but this is one way to do it.